CircuitPythonistas and sparkling sorcerers of code, it's Prof G, and in this lesson we're going to learn about sequences in CircuitPython, and while we learn about sequences, we're going to learn to light up individual NeoPixels on our board one by one instead of all the lights at once. While we'll demonstrate how to control the individual NeoPixel lights that are built into a Circuit Playground board, the exact same techniques will apply to addressing individual NeoPixel lights on a NeoPixel strand or strip of any length. Let's light them up! So as always, plug in your board and launch PyCharm. If you've been following our playlist in order, you probably have the infinite Roy G. Biv example up in your code.py file. We're going to use some of the code that we have in this so we don't need to type too much. If this file is not up, load it up now. And let's get into the REPL. Open PyCharm's terminal, launch TO. I'm going to use the up arrow key to find the last time I entered TO and press return. Stop the executing code with Control-C and type any key to get into the REPL. And we see the 3 chevrons, which is the REPL prompt. We're ready to rock REPL style. Now, in order to have some objects and variables to work with in the REPL, let's highlight the lines of code from the import statements through the last lines of color, copy them, paste them into the REPL. Great. And any NeoPixel lights that are on your board should now be white because we're in the REPL. So let's turn those lights off. Do you remember how to do that? Pixels.fill in parentheses black. This statement works because we've done our imports and we've defined pixels in black above. And we did that by pasting the code into the REPL. Now let's talk sequences. Sequences are a type of data structure in Python that allows data to be stored one after another. And we can access individual elements in a sequence by following the sequence variable name with square brackets that include an index number of the individual element that we want. Now, as you see up here, we've defined the NeoPixel object named Pixels, and we have 10 lights. Well, the NeoPixel class creates objects that are a sequence. Those lights are lined up one after another in the data structure. And there are certain commands that we can perform on a sequence. For example, we can find out the length of a sequence by using the len function, len for length. Try this, lowercase len, and in parentheses, pixels. Press return, and we get 10, because we got 10 NeoPixels in that Pixels NeoPixel object. Cool. Although rather expected. But even cooler, we can access each of the elements in a sequence by following the sequence variable's name with square brackets that contain an index. So if you want to work with a light at index 1 in our pixel sequence, just type this, lowercase pixels, square bracket. If you're not used to typing that, that's above and to the left of the return key on the US keyboard. Then type 1 so that we access the element that's at index 1. Then close square bracket, which is right next to the open square bracket. What happens if we press return right now? Hey, we see a color. Now it's black, lights off, in parentheses 0, 0, 0, but if pixels in brackets 1 gives us a color, can we set pixels in brackets 1 equal to a color? Let's try this. Up arrow so pixels bracket 1 shows up again, and let's set this equal to, in all caps, indigo, and gadzooks, my friends, will you look at that? We have a pixel lit up. Let's try some more. How about pixels, this time with 2, equals red? Nice. How about pixels, this time 3, equals blue? That is most groovy. Let's try pixels 9 equals green. Nice. How about pixels 10 equals orange? This is where we might run into a problem. Dang! Look at that error message. Index at a range. What happened there? Well, this brings us to an important point about how we count with computers. We don't start with 1, we start with 0. It's referred to as zero indexing. And it's not specific to Python. Nearly all programming languages are zero indexed, meaning we start counting at 0, not 1. Also, it's worth noting that we light up NeoPixels differently, whether we want to light them up all at once or one at a time. To light up all NeoPixels at once, we use the fill function, passing in a color between the parentheses. But to light up a single NeoPixel, follow the NeoPixel variable name with square brackets containing the index of the single light that you want to turn on, then set that equal to, so we use equal here, a color. So note the difference, all colors at once use the fill function, one color at a time, use the sequence index value, and then set this equal to a color. And now that we know this, we can tell we got the index out of range error because we were trying to pass in the number 10, which wasn't a valid number in the sequence because we only have 10 lights, but those are numbered 0 through 9. So 10 is an invalid index, it's out of range, hence the error. So let's try this. Pixels in square bracket 0 equals orange. Lights up orange, nice. Now you know how to address all of the lights individually on your NeoPixel board. The same thing applies to a NeoPixel strand or strip. So now is a good time for a challenge. This is the red and blue challenge. Get out of the REPL and work in code.py and write code to light up half of the pixels in red, half of the pixels in blue, just as you see here, and leave the lights on forever. Save your work as red and blue.py. You should be armed with the skills to make this happen. So pause. And when you think you got it, resume. And let's compare answers. So I'm going to make sure I'm clicked in the terminal, and I'm going to get out of the REPL first with Control-D, and then I'm going to click the terminal icon to hide the terminal, give myself more coding space, and I'm going to keep the imports pixel definition and all the colors, even though I'm not going to use them all. Let's see, I don't need the time interval here, and I'll set the colors before the while true loop. So I'm going to say pixels, bracket, 0, close bracket, equals, all caps red. Then I'll copy and paste this line 4 more times below it, and I'll change the indices from 1 through 4. And then below this, pixels, bracket 5, close bracket, equals all caps blue. Copy this line, paste it 4 times, and change the indices from 6 through 9. And in the while true, I don't need all of this code here, so I'm going to delete it. And instead, the only line I need inside of while true is pass, just a placeholder line. Then I can open the terminal back up. TO is already running. I'll click back in code.py and Command-S or Control-S to save, and we can see the half and half lights red and blue, very patriotic. Or at least for those of you that have flags with blue and red in them. And make sure you save this to your CircuitPython school folder as red-and-blue.py. And always remember to close that tab so you get back to code.py on your CircuitPy board. And just to mention, some of you might have put the lines that turn on the lights inside the while true loop, and that works too. But what this does is it constantly turns on lights that are already on. See how this will go forever, and each of these lines will turn on the lights? The effect for someone looking at the circuit playground is the same, but if we turn on all the lights once up here and then enter the infinite loop, that's really all we need to do. Now when we look at our code, we see something interesting. All these lines that turn on the code in red are identical except for the index values. Same for the blue lines. It would be really cool if we could write some code to just increment the values from, say, 0 to 4 or 5 to 9. Well, my friend, we can do this using the miraculous marvels that are for loops. That's for F-O-R. That's what's coming in our next lesson. We'll learn about various kinds of for loops, code them up, see their output, and then challenge you to use those techniques to light up NeoPixels. More big learning is afoot. Continue to hack.